How many of you drive gas-powered cars? If you do, like myself, then you know just how much money can go into paying for gas, especially when you think about the recent increase in prices that we've seen lately. The gasoline products that many of us use today are made from non-renewable resources such as fossil fuels, which we have a limited supply of. We could potentially see an even higher increase in prices as that supply becomes even more limited. These products also have a negative impact on our environment through the high amounts of pollution that are released by gases like carbon monoxide and nitrogen oxide. However, there are some alternatives out there, and one alternative that has been getting more attention lately is biofuels. Biofuels are made from renewable resources such as vegetable oils, animal fats, and even various plant parts. They can also be used as a substitute for petroleum and oil-powered machinery such as pipelines, pumps, tanks, and even vehicles. The two most commonly used biofuels today are ethanol and biodiesel. Ethanol is made from various plant material and it produces lower carbon monoxide and other smog-causing emissions. Biodiesel is made from new and used vegetable oil as well as animal fats, and this is a good substitute for petroleum because it burns cleaner, it's non-toxic, and it's biodegradable. However, there are some companies out there that are already looking into developing new biofuels from non-food-based resources such as cellulose or algae. Algae could be a good alternative because it can easily be grown in large quantities and it contains many fatty acids that could be used in the biofuel. This is where my research comes into play. My research focuses on the genetic background of a cryptophyte algae known as Hemiselmis cryptochromatica. This strain has demonstrated the ability to successfully photosynthesize or produce energy under multiple different light environments. They are able to do this by being able to absorb different wavelengths of light depending upon the light that is available to them. This is known as phenotypic plasticity, when an organism can alter its outward expression depending on its environment. My research aims to understand why this strain has this unique ability and the different photosynthetic processes. The more that we can learn and understand about the genetic mechanisms behind how different strains of algae can photosynthesize, the better we can use that information for new biofuels. Algae could potentially lead us away from the toxic petroleum products that we use now and will eventually run out of, as well as lead to lower air pollution.